Hey, and welcome back to the channel. Today, we will talk about the strategy pattern and how Spring injection can be used to create clean code that follows the solid principles of programming. All the relevant links and the GitHub code will be down in the description. Strategy pattern is one of the behavioral design patterns designed in the Gang of Four design patterns. It enables selecting a strategy at runtime. So, depending on the context, the correct strategy will be chosen and applied. Let's look at it with the help of an example. In this example, we have our order class, which creates the context. Then we have our payment strategy class, which is on the other side, the strategy, with concrete implementations, which are bank account payment, credit card payment strategy, and PayPal payment strategy. So basically, the user can create an order, then decide to pay for it in a different way depending on the context, right? So he can say, I want to play with my bank account, or I want to play with my credit card, or I would like to pay with PayPal. How does this come together? So order has an ID and total amount. In the payment strategy, a method which is called pay, which takes an order ID and amount. The order service, which works on the order, has a method called process order. This is where the order gets married with payment strategy. So it knows which payment strategy to use. And the implementation is pretty simple. And depending on the payment strategy that you choose, the correct strategy will be applied. So either the money will be taken from the bank account or the credit card or PayPal. Let's see how it works in the test. Here in this test, we have these three methods: should pay with bank account, should pay with credit card, and should pay with PayPal. In all these three methods, we use the same order which has been created in the setup, and then we call the process order, passing in the strategy that applies to that particular method. Let's run the test and look at the results. As you can see, each payment was executed with its respective payment strategy. That was an example of strategy pattern implemented in a classic way. That's how most of the tutorials on the internet will show you, and most of the people will implement it. But there's a big problem with it. Let's talk about the problem. Clean code states that there should be high cohesion and low coupling between modules. The two modules that we have in the example are the order and the payment strategy. As you can see that the order service, which is part of the order module, has complete access to the payment strategy. And it can call methods on payment strategy that it has no business calling. For example, it could call the method print monthly payment report, which is commented out here, but which has nothing to do with an order service. Also, if you want to split up this monolith into two microservices, one order microservice and another payment microservice, the high coupling will cause any small change in payment microservice to change the order microservice, which is not good. As you can see, this is not a good design. So let's see what other options we have. Option number 2. We can extend our interface payment strategy with a method getName. So each concrete implementation of payment strategy will get a unique name. For example, the bank account payment strategy has its own unique name, credit card has its own, and PayPal similarly has its own unique name. And this is the name that the order service will now use to call payment module. So instead of having a high coupling and integrating the complete interface into the order service, we just use the name. So how do we use this name? On the other side, on the payment strategy, we create a payment strategy service class. First, I show you the bad example of it. So we have a payment strategy service class where we auto-wire all the concrete implementations and then obviously use an if-else. And when we find the right one, we call the method pay or throw an unsupported exception. Now this is a bad example because one of the solid principles says the class should be open-close. That means it should be open for extension but closed for changes. Here, this class is open for extension but it's not closed for changes because as soon as we have a new payment strategy, let's say pay by Bitcoin or whatever, this strategy will have to be implemented and then auto-wired here. So this service class will have to be extended. So now I will show you a good example of payment strategy service class where we will utilize the Spring injection to get rid of this open-close problem. This is a better example of payment strategy service where we have a list of payment strategy interface and an annotation auto-wired. What Spring does here is its magic. It realizes that we auto-wiring a list of interface and it will automatically auto-wire every single implementation of this interface in there. So if in the future we have a new implementation, Bitcoin payment strategy, that will automatically be part of it. And all we have to do in our process payment method is go through it, stream it, filter it, find the first one, call the method, and if not found, throw the unsupported exception. Let's talk about a couple of other ways the same could be implemented. Here's the third example of payment strategy service. As you can see, we auto wire a map here instead of a list, but the Spring magic still works. So Spring realizes that the map is of an interface and it auto wires every single implementation of this interface in the map. Now, how do we use it? You go back to our order service impl class and see that we will pass on the payment strategy name. But the difference is this payment strategy name is not the name as we define in our concrete implementation. Let's look at the test and it will be clear in a second. As you can see, that the name that we have to provide is not the name that we define in our concrete class, but the name of the bean. That's the bad part, because if we ever go and change the name of the bean, suddenly the contract breaks with the order service. We can go ahead and make it simpler and better. I will show you another example. So in this example, we do have a map, but we still auto wire a list in there. And what we do is we loop through the list and fill the map key as the name of the strategy. So the name that we define in the concrete implementation. And this we can see in the test. We are back to the test and we are using the name that we define in the concrete implementation, which loosens up the coupling between the two modules, the order and the payment. Let's do a recap of what we learned so far. We looked at the theory. What is strategy pattern? Then we looked at the classic way of implementing it and saw why it is bad. And after that, we saw a better way of implementing it using Spring injection. And now let's look at a fancier example and then decide for ourselves if it is a good way or a bad way. I saw this design in one of the mailing lists of D-Zone magazine yesterday. This uses two features. Number one, the default method in Java interface introduced in Java 8. And number two, Spring AutoWire. Fifth implementation of our payment strategy interface, we have a new default method called register context. In this method, we AutoWire order service and it calls the order service.register strategy method. Let's look at it, what it method does. Order service has a map of payment strategies. The register strategy takes the concrete implementation and puts it into the map using the name. And then you can use the map to get the strategy and then call the pay method. Let's look at the test. Like our list example, or the map example where you use the name as the key, works similarly. So you just call the process order, it gets the name, through the name you get the strategy from the map and then call the pay method. If you think about it, this example has again a very high coupling because order service knows a lot about payment strategy. It gets complete hold on the handle on it, right? So from my point of view, this is not a good design. Let me know in the comments what you think about it. So that was my take on strategy pattern. If you like the video, like and subscribe and leave a comment. Till next time.